recently I came up with a side project idea that involves working with Markdown. And there's a very, I guess, stable C library out there that's called CMark, which is written in pure C, that I think I'm going to use. And in this video, I'm going to demonstrate how to wrap that library so that we can use it in Swift projects. Let's get started. Okay, so the first thing I'm going to do is to make a workspace for our work here. And then let's go download the CMark library. So if you just Google CMark, yeah, let's just go to the latest release and grab the source code. And then let's unzip it. So let's take a look at what's in the package. I see a CMake file and the make file. So that typically indicates this project is probably built with CMake, with the make file being some kind of a convenient command dispatch kind of thing. So I'm going to take a look at that. A bunch of variables, and here are all the phony targets. Okay, so we can choose to build all, or I guess CMake build probably is what we want because the rest looks like it's for development, either running sanitizers or benchmarking and stuff like that. So make CMake build. Okay. And here we go. We're building everything I believe is in the build folder. Okay, so it's beneficial to run a build and make sure that, at least on this computer, I have the necessary tools. We've built a static library called libcmark. The target name would be libcmark static. Okay, I'm just gonna search for this string. And we've got a bunch of results. Can't imagine this many references in the source code. So how about this in the source directory? Okay, so this is more like what I'm looking for. Going there, I'm assuming there's gonna be an add library somewhere. Yeah, add library is adding the static library variable, which is defined here. Okay, so these are the files that the library target uses. So if we just browse it a bit, you'll notice it's mainly just C files and headers, right? Then there's the CMake list that we just looked at. And then, okay, main.c is interesting, but we already have the list for the library. This is the part of the code that we're interested in, like the library part of the package. So I'm gonna sort it. I guess we can just save it in a different file. List, okay. So here we are. I do want to copy all these files somewhere. Yeah, let's do that. Let's just try some shell command. We can cat the list, right? That shows the list. And then we can pipe that into xargs. And what if I just do echo? This should work, right? Okay, so basically took each line in the file and echoed it. And then, well, let's make a folder for this. CMark. Well, run our cat and xarg combo. We're gonna copy files from this list into our CMark folder. CMark source, this CMark. And here we go. There are all the files we're interested in. I think it's time to think about Swift. Our plan is to make a Swift PM project that builds these C files as a target and then use a different target to import that interface. I'm gonna call this project scmark. So I guess we'll just make a new package. We'll give this an edit. As I mentioned earlier, I want another target, CMark. It's kind of a convention. I don't know where it came from. The target for the C code starts with the uppercase C, and this target will not have any dependency, and then we'll make our Swift target depend on CMark. Now let's make the folders for our new target, which is in our workspace. So we can move the CMark into sources. All right, so what happens if I just try to build this, right? Now we have a new target, has some C files. Let's see what happens. So we're missing some header files. I'm guessing these files are generated with some input from CMake. So let's take a look at the original files. So let's see config.h. Yeah, sure enough, there's a config.h.in. As you can see, there's some mention of CMake define, blah, blah, blah. For now, I'm just gonna bypass this and say, we know this build, so those files must exist somewhere in here. So I'm gonna just go up a level, try to find that file. So config.h, and we know it's probably generated, so it's gonna end up in the build folder. Let's take a look. So I'm just gonna take this result and copy that into our source. Okay, this is some fish syntax, and let's build that again. Another one, no problem. We know how to deal with this. CMark export. Okay, so CMark export, it's a local header while we're using brackets. Entities.inc. Missing required module Swift shims. To make Swift PM build module, we need to give it the module map. I'm gonna add a new folder here called include. I guess we need to identify the primary interface that this module exports. Assume is in CMark, right? By the description of this, we probably can guess at least this piece is the public interface. So move that there, and then we will write a module map. Say this is a module, let's call it CMark, and it will have a header. Probably not, yes, because we're missing those headers. So let's move those headers. Can move this to include. Okay, let's give that a try again. There we go. We just built the module. We got some warnings here. This is probably because I'm using Swift 5.3. So let's see. So for this target, let's add some resources. Process or something like that. You know what? I actually like the idea of having everything in a separate folder. So let's do that. Okay, let's take a look at the list of resources we need to do. I guess I'll just take them here, paste. I'm gonna assume this works. Okay, let's build again. There we go. We built the project without any error. Next, let's go to our Swift module and let's import CMark and see what happens. Swift build, and we just built it. Let's try to use one of these functions. Let's use the first one that we looked at earlier. It takes some C string, which is very convenient in Swift to do. So, okay, and in here, we just straight up reference this. You can use text. And then the length would be utf8.count. Options, let's see, options. I'm assuming these are the options. Let's try using this thing. Of course, it's going to return a C string. So let's wrap that back into our string. Yeah, now we have a Swift function. Translates Markdown to HTML. Write a test and see if it works. Let's just xct assert and let's run that test again. Build. Test. And we passed the test. We wrapped CMark in a Swift PM package and used it. And the next step, wrap more stuff from the header file so that you get more functionality from the C library. But for now, I think that's it for our video. Thanks for watching. See you next time.